All right, and our second video here for week 5, this one probably we're going to get these next 2 pages done in just this one video. This is pretty short. We're just going back to the concept of geometric areas and geometric volumes. So we'll start with geometric areas on this page. These are all common areas of geometric shapes that you should know. So we need to make sure that we are remembering these. So the first one is just the area of a triangle. If you guys remember, the area of a triangle is 1/2 base times height. Okay, in this particular case, the triangle is a right triangle. So we have a base. We have 21 as a base. 29 is the hypotenuse, so it's not either one of them. We need to find the height. So what we need to do is we need to use a little Pythagorean theorem here in order to find the height. So if you guys remember, the Pythagorean theorem is a squared plus b squared equals c squared, or x squared plus y squared equals z squared, whatever you want to do. It's the square of the two sides, or the two legs, added together equals the square of the hypotenuse. So we're going to have 21 squared plus, and we'll just call it b squared in this case, equals 29 squared. Okay, and these are not values that I typically remember right off the top of my head. I know most of my squares up through 20. I don't remember 21 and 29. So I'm just going to go ahead and plug those two things into a calculator and see what I get. So 29 squared is 841. 21 squared is 441. So we'll subtract 441 on both sides, and we're going to get 400. This is really nice. This is actually a special right triangle because that means that b, which is the square root of 400, is 20. In this case, we did solve an equation where we had b squared equals 400, so we technically took the square root of both sides. We should have had a plus or a minus mathematically in front of that 20. However, since it's the side of a triangle, we don't need to worry about the minus because there is no such thing as a negative length. So we've got 20. So now we have the base and we have the height. The rest of this should be pretty easy to do. So 1/2 the base times the height means that the area of this is going to be 1/2 the base, which is 21, times the height, which is 20. Now remember that you can multiply and divide in any order as long as you keep it consistent. So I don't have to do 1/2 of 21 first. I could do 1/2 of 20 first. Makes it a lot easier. So this is just a way to do some mental math. 1/2 of 20 is 10, and then 10 times 21 is 210. So there's my area, 210 square centimeters. Okay, another common area that we have to deal with is a circle. Circle area, if you guys remember, is pi r squared. So the most important thing there we need is r. They gave us r. This one's going to be really simple. R is 6, so in this case the area is going to be pi times 6 squared, which is just 36 times pi. In most cases, from, excuse me, from now on, you're going to want to leave pi as pi. We don't want to use the decimal approximation unless somebody actually tells us to. And once again, it's an area, so the units are square centimeters. Okay, number 3. It's another triangle. This one, however, is not a right triangle. The area is still base 1/2 base times height. That doesn't change. Area is 1/2 base times height. Well, in this case, I have a base. The base is 10, and it doesn't matter which way you turn the triangle, the base is going to be 10. So this is actually an equilateral triangle. Well, in order for us to actually figure out the height of this thing, you can choose to memorize it. There's an actual formula for this you can choose to memorize. I prefer to actually have people think about how this works. So the idea is this. If I want to find the height is drawn from one of the vertices perpendicular to the other side. So I'm going to start here, just the easiest one, and drop a perpendicular to the other side. Well, because all of these sides are the same, they're all 10s, it's going to make this real easy, because what that does is this creates two sides down here of 5. So this piece right here is 5 inches, and this piece right here is 5 inches. And if I just focus on this triangle over here to the right side, I just focus on this piece right here, what I can see is that now what I actually have, because it was an equilateral triangle, I've cut this angle right here in half. So from 60, now it comes down to 30. This right here is 60. So what I've created is a 30, 60, 90 right triangle. Going back to properties of 30, 60, 90 right triangles, I have the short side as 5 inches. I know that the long side is 5 inches times the square root of 3 in a 30, 60, 90 right triangle. So what that gives me is that this height is 5 square root of 3 inches. My 5s keep looking horrible because they drag that bottom. There we go. 5 square root of 3 inches. So now I have my height. So the area is 1/2. The base, the entire base is 10 times the height, which is 5 square root of 3. So 1/2 of 10 is 5 times 5 square root of 3 gives us 25 square root of 3. And once again, square inches. We are in area. So there's our area. Okay, last piece is parallelogram. I'm sorry, not parallelogram. What am I thinking? This is a trapezoid. Couple of properties of a trapezoid. Trapezoids have multiple bases. Bases are parallel to each other. This side and this side are parallel. Didn't have to write those arrows in there because of the fact that we were given that that's a right angle and that's a right angle, automatically indicating that the two bases here were parallel to each other. The height of a trapezoid is perpendicular to both of the bases. So what that means is that 15 here is your height. The 12 on top is a base. The 20 on the bottom is a base. The 17 here actually doesn't mean anything to finding the area. So if you don't remember the area of a trapezoid, I always like to give people this little tidbit. A trapezoid is actually a triangle. If I were to take that that perpendicular base, and I were to slide it all the way over to here, and then ignore the square on the left, if you kind of cover up the square on the left-hand side, all you have left is a triangle. Well, all that did was it took the base 1 on the top, it took that down to a 0 length. And then down here on the bottom, right here, you'd still have a base. And really all you have is a triangle where one of the bases is 0. So if you can remember what the area of a triangle is, and usually we can, you can figure out the area of a trapezoid, because all the area of a trapezoid is the same thing as a triangle, but you're adding two bases together. So area of a trapezoid is 1/2. I've got two bases to add together, and then times the height. So base 1 plus base 2. So the area of a trapezoid here is 1/2, the first base, which is 12, the second base, which is 20, and the height is 15. So let's see, we're going to have 1/2, 12 plus 20 is 32, times 15. 1/2 of 32 is 16. So our area is going to be 16 times 15, which is going to be, I think that is 240, if I'm not mistaken. 160 plus 80, yeah, 240. And centimeters squared. There's your area. All right, took a little bit longer than I thought, so we will come back with a third video for the volumes.